Hello and welcome. We're going to begin today by talking about what is engineering economics or engineering economy. You'll hear these two words, economics or economy, kind of thrown around. They both mean the same thing. They're referring to the same subject. I believe the newer version of the most used one right now is engineering economics, but engineering economy, if you hear it referred to that way, that's fine. So, what is engineering economy all about? Okay, so the fancy definition says engineering economy involves a systematic evaluation of the economic merits of proposed solutions to engineering problems. So, what is this really telling us? It's telling us that we need to consider the economic aspect of our plans, the economic aspect of our engineering design when designing and when even contemplating creating something. And what this means is that this is going to play a huge role in our decision making process. So, at the end of the day, engineering economics is all about decision making, providing us the information and the economic tools to make an informed decision. Sometimes we're going to compare between alternatives, or sometimes we're just going to try to find out whether an alternative is economically feasible. So, solutions to engineering problems must be economically acceptable. Obviously, if something is not economically acceptable or economically feasible, then it's just not going to work. It's not worth doing. So, we need to properly analyze all of the information from the financial side of things to make a good decision. You can have a beautiful design, but if it's not economically feasible, then you can't do anything with it. So, our engineering economic analysis focuses on the cost, revenues, and benefits that occur at different times. So, here's the keyword time. Time plays a huge role here because time has value. Money has value over time. I was about to say that backwards. And that is the most important concept in engineering economic analysis, and we will get to that part later. So you might be thinking, well, I'm going to become an electrical engineer or a civil engineer. How is this relevant? It's relevant to all different engineering majors because as you progress in your studies and as you start designing things, you have to consider the economic impact of the decisions you're making. So if you're a civil, you're going to be working with, say, you're going to be designing this bridge, but you need to also plan you need to make decisions about materials, about timing, about how this is going to be financed. So again, you need to understand this. Industrial, so manufacturing and logistics, actually industrial engineering, that's usually where this class in a college that has several engineering majors, engineering economics is either part of the civil engineering department or industrial engineering department. Now, that's not to say that mechanical or electrical can't use it, because they too need to make decisions, and they need these decisions to be economically sound, of course. Okay, so what are some of the principles of engineering economics? So we're going to go through these very briefly, but you're going to see that with time they're going to keep coming up. So what am I referring to? These principles. Oh, they don't want to pop up. There we go. First of all, develop alternatives. So develop alternatives involves the fact that if you don't know all of the alternatives, then your decision might not be the most the best option for you. Next, we're going to focus on the differences. So only the differences in expected future outcomes among the alternatives are relevant, and those are the ones that are going to be considered in the decision. So in other words, all things being equal, if everything else is equal, then you must find those differences, and those are the ones that are going to help you make your decision. Third, we're going to use a consistent viewpoint. So because we're talking about time, you have to take everything from the same time, but also viewpoint. The two viewpoints that we're going to go back and forth between is, are we viewing it from the point of view of the costs or of the benefits? So if you see it from the point of view of the benefits, then all benefits are positive and all costs would be negative. But if you see it from the point of view of cost, then all your costs will be positive and your benefits will be negative in your equations. So that's what this is kind of saying. Use a common unit of measure. So we're going to be talking about money, and you might be thinking, well, money is money. But that's not necessarily true, because today's money is not the same as tomorrow's money. We have interest, compound interest and simple interest to take into account, as well as other factors such as inflation and deflation. So consider all relevant data. Well, this sounds like it should be obvious. But what this is saying is that the decision process should consider both the outcomes enumerated in the monetary, like all the money-wise decisions, and also, but it doesn't just have to be income and like revenue, profit, all of that stuff. There can be a numerical value to say environmental impact. So that could be relevant data in some of the cases. Make risk and uncertainty explicit. We're not going to get too far into this whole risk and uncertainty thing in class. I think we're going to talk about it at the very end of the class. However, what we have to make sure is that if there is risk and uncertainty, to at least not, we're going to ignore it for the time being, but in reality it's something that very much needs to play a role in analysis. And the only reason we're ignoring is because we're going to build up to that point and revisit your decisions. So at the end of the day, you're making decisions based on estimates, and estimates are not always what they were estimated to be. And with that in mind, we need to make sure we evaluate whether that was accurate, because it'll give us information about how to improve in the future. Okay, now let's talk about the decision-making process. So first, recognize the problem. Next, define the goal or objective. Third, assemble relevant data. Fourth, identify feasible alternatives. Then select the criterion to determine the best alternative. Construct a model. Predict each alternative's outcomes or consequences. Choose the best alternative and audit the result. So here, I could talk about this in further detail. I'm going to keep it brief. Recognizing the problem, that's self-explanatory. Defining the goal or objective. This is important because it's not the same to say pay off student loans versus pay off student loans by May. The economic plan to achieve each one of those can look vastly different. Assemble relevant data, so qualitative versus quantitative. Quantitative is numbers. Qualitative is something that can't be measured in numbers, but it can be assigned numerical value so that we can then treat it in a quantitative matter if that's what we need. So we're going to make sure to know things about the cost, the price, the time, the project information, and to be aware of market consequences and intangible consequences. So by that it means the market price. For instance, if you're selling a vehicle, the market value of something changes every day, and that might have a huge role in your decision-making process. So identify feasible alternatives. You need to brainstorm to make sure that you're thinking of all different potential solutions. We're going to select the criterion to determine the best alternative. So first, what is best? Does that mean most profitable, highest revenue, least cost? Does it mean least? It could also be things like least environmental impact, minimize unemployment, minimize time. So depending on that objective that you're trying to achieve, that's going to change what your analysis will look like. And most engineering problems in this class will be about maximizing profit, not that that's the only objective out there. Constructing a model. So based on the data that we have been given, we will be able to find the mathematical relationship between the variables and set them up in a way that help us do the calculations, which will yield results that we can work with. Predicting the outcomes of each alternative. So we can do these things called cash flow diagrams, and here's where estimation plays a role. So we're going to estimate some of the benefits, we're going to estimate some of the costs, and based on those estimations we're going to do this analysis. So we're going to choose the best alternative, which is not always as easy as it seems, because there's trade-offs. And finally, audit the results. So this kind of mirrors what we talked about earlier about the principles of engineering economy. So I'm going to stop the video here. In the next video, we're going to talk about engineering ethics.